Hello everyone, how are you doing? In this short video, we will talk about a new type of integrals that in many textbooks they call it line integrals. But when they write it with a subscript of C, means curve integrals. And this one is nothing except integrating over a smooth path. And it is possible for some of you have said, what is a smooth path? If you have a path either in R2 or R1 or R3, this one is in R3, these are I hat, J hat, and a K hat. A smooth path means your dx dt and your dy dt cannot become equal to 0 simultaneously. Yes, dx dt can be equal to 0 at a specific time, but not at the same time as dy it is. It had to be at a different time. Therefore, in order to be a smooth path, if simultaneously both of them become 0, you create a cusp, and that's not called a smooth path. Same thing with the R3, your dx dt and dy dt and dz dt, they cannot become equal to each other and simultaneously become equal to 0. That's one thing you should know about the smooth path. Also, therefore, this is a curve integrals over a smooth path, and this is nothing except the arc length. Remember, arc length consists of many line segments, and if you want to find the arc length, you have to find the length of one line segment and use integral to sum this one up. Therefore, if this point is first point, call it xy y1, I call this one x2 y2. Therefore, this is the change in x, and this one is the change in y. That distance is nothing except square root of a square plus b square. But if you want to sum this one up, and that's become an arc length, that's called the change in s, you have to integrate it. But integration, you need a variable of integration here. Well, as I said in the previous video, if I want to do it with respect to x, I need dx, but I only need dx on the top. I can bring the dx on the bottom right here and square it and keep it under radical to get rid of it over here. Therefore, this is dx over dx, which is 1, and that's dy over dx, which is y prime square, and that's become a dx. And that was the arc length over from x equal to a x equal to b, and that was the arc length respect to x when the x is fixed. But somebody said, what happened if I wanted respect to y? Here you have to put dy and bring the dy here, and that's become x prime, and that's dy over dy squared is 1. Therefore, here your y is fixed from c to d, and this become 1 plus x prime squared dy. But somebody said, what happened if I wanted respect to t? Well, you keep the dt here, you bring the t on the other side. Therefore, here your arc length become from t equal to a, t equal to b, and this become dx dt squared plus dy dt squared dt. And that's the arc length in parametric function. But somebody said, what happened if I wanted respect to theta? Well, you put d theta over d theta and bring the d theta underneath, and that's become nothing except the arc length when theta is equal to alpha and theta to equal to a beta of dx over d theta square plus dy over d theta square d theta. And if you simplify that, if you remember in calculus 2, this one called r prime square plus r square d theta, and that would become in polar form. But in this one, I need this one. And what is dx dt? Is the derivative of that. And what is dy dt? That's the derivative of the y component. And the square root of this square of a sum of the square is nothing except the magnitude. Then from today you have to know the arc length, which is s, from t equal to a, t equal to b, is the magnitude of r prime of t dt. You have to know that because when I do the line integral, that's what you replace with your ds. Somebody said, okay, therefore if you want to do a line integrals of function of x and a y, and you want to put a ds right here, I can easily change this one to a definite integral by replacing this one t equal to a, t equal to b, and instead of a ds you put r prime of t dt. But what am I gonna do with that x and y? The function of x and y, you have no choice to parameterize it as a function of t. Therefore, from today you have to know that if you do have a line integral of f of x, y, ds, that's equal to the sum of a delta, this is called the norm, as approaches 0, of this sum, I'm sorry, that should be, that's the limit of the norm approaches 0 of the sum of in I equal to 1 to n number of them, and this one become xi, yi, and that become delta si. And delta si is picking one of these line segments right here, and that's how you do the line integrals in the R2. But somebody say, what happens if I want to do it in the space? In a space, you're going to have function of x, y, z, and you multiply by ds. And that's the arc length in the space. And that's nothing except the limit as the norm approaches 0. And somebody say, what is a norm? In calculus 1, you understood if you do have a rectangle, but as you go forward, the dx getting bigger and bigger and bigger. Norm means this is called norm. The largest one has to approach 0. If the largest one approaches 0, then I bet you this approach 0 long before this one does, and this one approaches 0 long before this one does. That this one called the largest change in t right here. And that becomes the sum of I equal to 1 through n of f of the ith piece of ds delta si. Okay, and this is nothing except limit provided, and the limit provided means that has to become a smooth curve. Therefore, somebody said, what happens if I have a line integral of f of x and a y ds? How do I change this one to a definite integral that I'll be able to integrate it? Remember, all the line integrals eventually have to become a definite integrals. In here, you have to go and take that x as the same parameter as your arc length. Therefore, I call it x of t, y of t, and here you have to write your arc length, which is the square. Here you have two choices. You can put r prime of t dt, or in here you can write dx dt square plus dy dt square dt. Therefore, you have to do this one for if you have a function of 2 variables, and if you have function of 3 variables like f of x, y, and z of ds, this become the x have to become parameterized, the y has to become a parameterized, the z has to become parameterized, and you have to multiply by the arc length. In this case, it's going to be dx dt square plus dy over dt square plus dz over dt square dt. Therefore, this is nothing except changing a line integral into a definite integral from t equal to a to t equal to b. And remember, a has to be less than a b. But my question is here, somebody said, what happened if this integrand become 1? Don't feel bad, because if this become 1, that will become the arc length. If this become a density, that become the math of the path. If this become a force times distance, that become work. Therefore, it depends what your integrand it is. Therefore, by doing that integrand, you'll be okay. Let's make an example. Okay, I'm gonna have a line integral of x squared minus a y plus, maybe I pick 3z, over some path. And somebody gonna say, what is your path right here? I said my path, I'm gonna make this one up, and your path, I'm gonna get it from here to here, and my path in here, my x is 1, my y is 2, and my z is 1. What did that mean? It means you go 1 unit here, 2 unit here, and 1 unit here. You get to that point. Therefore, this is my path from 0, 0, 0. Okay, but this is your x, this is your y, this is your z. Right now you have an option. You said, I am a turtle, and I take my time. It takes me 5 minutes to get from here to here. Therefore, your x of t is 5t. When t is 0, you get 0. When the t is, it takes 5 seconds. And when the t is 1, let me see. If it takes 5 seconds, that become 1/5 of t. And when the t become 5 seconds, that become 1. Your y of t is 2/5 of a t. If t is 0, you get 0. When the t is 5, you get 2. And your z of t is 1/5 of t. When the t is 0, you get 0. When the t is 5, you get that. But somebody said, I want to be a frog, and it takes me 1 second. Well, your x of t is 1t. 0, 0, 1, 1. Your y of t is 2t. t0, 0, t1, 2. Z of t equal to 1t. 0 is t, 0 is 0, and 1 is 1. Therefore, I parameterized this path, and this is the parameterized path. And I can write this one as r of t equal to 1, 2, 1t, 2t, and 1t. Therefore, this must be a smooth curve from t equal to 0 to t equal to 1. Between 0 and 1, you cannot have any kind of a discontinuity. I got the pass. And you told me how long it take you? 1 second. Therefore, the integral of a line curve of x squared minus a y plus a 3z, ds become from t equal to 0 to t equal to 1 second. But instead of x squared, you're going to put t squared. Instead of the y, you put 2t. And instead of a z, you put 1t. And instead of a ds, you're going to put the square root of dx dt square, dy dt square, and dz dt square dt. And that's become a beautiful definite integrals, and you're going to evaluate it. That's t squared plus a t. t squared plus a t. 1 plus 4 is 5. 5 plus 1 is 6. That is a constant. I'll put the square root of 6 in here and dt. And you go from t equal to 0 to t equal to 1. And that become equal to square root of 6 t cubed over 3 plus t squared over 2 from t equal to 0 to 1, and that become 1/3 plus 1/2, and that become 5 over 6. 5 square root of 3 over 6. If this is called, it depends what your integrand it is, and if this is a density, therefore that would become the mass, and that would become a pound or whatever it is. Therefore, in order to be able to do the line integrals, you have to learn how to parameterize your path. Sometimes they give you the path, but if it's simple, you can parameterize. But sometimes somebody said, you know what, maybe you give me a path, and I said I must go from here, I must go from here, I must go from here, then this is my path. And how am I going to do that? Well, you can do the line integral over this path, you can the line integral over this path, and do the line integral over that path, just like we did a definite integral. Call this one C1, call this one C2, and so I'll call this one C3. Therefore, if you have a line integral of f of x, y, z ds, you can write it C1 f of x, y, z ds plus over the C2 f of x, y, z over ds, and plus a C3 f of x, y, z, and a ds. And this is how we did even in the definite integral. Somebody said, what do you mean by that? Well, I might give you an integrand. I don't know what that integrand represents. It depends on the subject you are taking, but they're going to give you that integrand and they're going to say, do it over that path. And you're going to ask them, what is your path? They said your path is, you go here to here, and you go to here to here. But that point is 1 and 1. This is a path, this is a path. But in here, you have an option. I'm going to write this one. From here to here, I'm going to take 1 minute. From here to here, it's going to take me another minute. Therefore, the first minute I'm here, which my t is between 1 and a 0, and that's what I'm going to do. But I have to go back on the next one and say, what am I going to do with the next one? That t has to be between 0 and 1, and between 1 and 2. Therefore, whatever you pick at the path, when I put 1, these two ends has to be the same. And when I put 2, you have to reach the end point. Somebody said, here I can put y equal to x squared because I get 1 and 1. Somebody said y equal to x cubed, I get 1 and 1. It depends which one they give you. Usually they're not going to let it up to you, because if they let it up to you, then instructor have to have infinitely many keys to check your work. Therefore, I'm going to say, okay, this path do it over y equal to x, and this one do it y over x squared. I said, okay, what is that point right here? 0, 0. Therefore, I need something for x. When I put 1, I get the 1. When I put 0, I get a 0, and that's t. And I can do the same thing for the y. 0, 0, 1, 1. Therefore, from here to here, I write that path, and that path is t and a t. But that t is only good between 1 and a 0. But somebody said, how about that one? Remember, that t is between 2 and a 1. Therefore, if I put y equal to t squared and put x equal to t, let me see. When I put 1, I get 1, and that matches with that one. But what am I gonna do with the y? Somebody said, okay, I'll put t squared. When I put 1, you do get 1. But when you put 2, I don't get 0. And here when I put 2, I don't get 0. That's not a good choice. Maybe I need to start thinking about that. Maybe I need to go in here and say, okay, maybe I have already used 1 minute of my time and said I put x of my t equal to 1 minus a t. Okay, 1 minus a t. When I put 1 here, I get 0, which I don't like it, because when it's 1 over t, 1 minus a t, between 1 and a 0, it depends if I want to take this one. Let me put 2 minus a 0. Okay. When I put t1, I get 1. And when I put t2, I get a 0. Oh, that looks beautiful. But what happens if I put my y of t equal to 2 minus t squared? Let me think. When I put 1, I get a 1. When I put 2, I get a 0. Oh, I parameterize that also. Therefore, between 1 and 2, I have to use 2 minus a t and 2 minus a t squared, and that's become your r of t whenever the t is between 2 and a 1. Therefore, I want to know along that path, and I'm going to write. First, I do the C1. The C1 x ds1. And I'm going to write this one as my x. Let me write the x by itself. But what is my ds? ds is the arc length. Is dt, dx dt squared plus dy dt squared. And that's 1 squared plus 1 squared dt. But the t go from 0 to 1. But what is my x in here? You have to do it according to the path. I don't have any y, but my x is a t. And this is nothing except the square root of 2, t squared over a 2 from 0 to 1, and that becomes square root of 2 over 2. That's only for that path. But how about the C2, which is x ds2, where on a C2 my x was 2 minus a t, and t was from 1 to 2. And what is my arc length? What is the derivative of dx dt? Is -1 squared. Plus, what is the derivative of dy dt? Is 2 times 2 minus a t to the power of 1 times to the power of -1 squared dt. Therefore, that problem becomes t equal to 1, t equal to 2, 2 minus a t. Let me see what happened inside the radical. I have 1. -1 squared is 1. In here I have a 4. Then I have plus 4, 2 minus a t squared dt. Therefore, this one is 4 minus a 4t plus a t squared. That's become 1 plus a 16 minus a 16t plus a 4t squared. That's make it a 17. You know that problem get a little bitty tedious. And let's see if we can finish that. Your t is equal to 1 to t equal to 2, 2 minus a t square root of 17 minus 16t plus 4t squared dt. Well, if I want to take the derivative inside, it's going to become negative 16 plus 8t. Maybe I have something like that. I have that outside. Therefore, if I take this one a u, my du is outside, but I need a negative 16 plus 8t. What happens if I multiply by negative 8 and divide it by negative 8? Is that negative 16 plus 8t? 100% right. Therefore, if I take my u to become 17 minus 16t plus 4t squared, your du is 16t minus 16 dt. Okay, I have negative 1 over 8. 1 to, no, I'm not, do you want me to change the limit of integration? If I do that, I have to put t equal to 1 right here and change it to u. Let me do that. When the t is 1, is 17 minus 16 is 1. 1 plus 4, let's make it a 5. When it's 2, let's make it 16. 16 and 17 is 33. But negative 16 times 2 is negative 32. Therefore, you get 1. And that's become square root of u du. But these lower limit and upper limit, this is upper, this is lower. I have to change the sign. Therefore, I flip it and change the sign. It becomes negative 1 over 8. 1 through 5 u to the power of 1/2 du, and that's become 1/8 of u to the power of 3/2 times 2/3 of 1 through 5, and that's make it 1 over 12 because 3 times 4. 5 to the power of 3/2 minus 1 because 1 to the power of 3/2 is there. This one is only integrated over C2. Then what was the integral of C x ds? That was exactly square root of 2 over 2, that was for your C1, plus 1 over 12 of 5 to the power of 3/2 minus a 1, and that was over a C2. Therefore, really don't be so picky about the line integrals. It's very much look like a definite integrals, but you have to do it over a smooth curve and you have to parameterize your path. But eventually somebody gonna say, okay, if I parameterize it over the path, then what happened to my integrand? If I pick any, what happened to it become a vector field, or what happened because in the next video we're going to talk about it. What happened if this path go inside a tornadoes, and tornado pick an object from here and move it over here and put it back here? How much work it has done, and what is the line integrals over a vector field? Then please pay attention, we have two types of line integrals. One, they call scalar line integrals. A scalar means this is only a scalar quantity like a function of x, y, z or x, y. But sometimes you have a line integral, you have a vector field, and then you have a ds. Therefore, this is nothing except a vector. And how we going to integrate the line integral if this become a vector field? And I hope we get it over the next video. Thank you.